Recording now. We're going to learn about the cross product. And like it says here, the cross product is an operation between two vectors that returns a vector that is perpendicular to both vectors. So whereas the dot product returns a scalar quantity, meaning just a number, the cross product returns a vector that has both a magnitude and a direction. So it returns an actual vector. Okay? This formula is very complicated to kind of see, so it's much easier to figure out the cross product using, this is called a determinant. Well, not like a matrix, except a determinant you actually calculate something from, okay? And this determinant will tell you what numbers go in here and stuff, and you just have to kind of know how to do it. So in other words, if I want to, is this an arrow? Is that going to be an arrow if I draw it? Yeah, if I wanted to return a, if I have two vectors out here in space, let's say this is space, okay? If I find the cross product of those two vectors, I'm going to get another vector out here somewhere that, even though it doesn't look like it, is perpendicular to this vector and is also perpendicular to this vector. Does that work? No.
If it's in space.
If it's in space, it would be.
No,
Can you graph it on that thing?
Yeah, the one on the left.
Oh, that's not very good. So
one going on.
it would be kind of.
Listen to the dude sitting up the front. He's smart.
Okay. So it would be kind of perpendicular. How can I draw that? Like that?
Well, is the line on the left going straight back? Because that way it would be all perfect.
Oh, I thought it was going straight up.
Yeah. Well, I could show you.
I thought the one in the middle was going straight
The middle
up.
one's going straight up.
Yeah.
It can be perpendicular.
Isn't that like a box in a corner of a
Yeah,
box?
this would be like the side of a box or
Yeah.
something, and this would be a
So it'd be
vector.
right.
or
I see
something.
what you're
What?
saying.
Yeah, so it's perpendicular to both of those. That's kind of a bad picture, but it works. So anyway, and the cross product is used a lot for determining forces on things in physics, and you might have heard of something called what's it called? The Kramer's rule, I think, or the left-hand rule, where this times this gives you this, and it has to do with physics. I don't remember exactly what about physics it does. But anyway, V cross W, to determine what V cross W is, which is a vector, you would do this matrix. So the way you do a simple, not matrix determinant, the way you do a simple determinant is multiplying that times that and that times that. So this determinant would give you a value of 2 times 2, which is 4, and then you subtract these two things, 1 times 3, which is 3, and so the value of that determinant is 1. And your calculator could even evaluate determinants for you, but that's not very useful for doing cross products because we're not really trying to find the value of this determinant. We're trying to find, I'll show you, okay? So in order to find a cross product, with this determinant, what you did, have any of you guys ever done determinants before? Yes? No? So what you do is you cross out this right here, the first row in the first column, and you take the determinant, this determinant right here, okay? So the value of this determinant is going to be, A, first you multiply it times A, okay, times the determinant 3, 5, 2, 3, which gives you 3 times 3 minus 2 times 5. See that? You multiply this times this and you multiply that times that. Then, just the way it works, the next thing is a minus sign. It goes plus, minus, plus. Then you go minus B. And then what you do is you cross out this B's column and B's row, and you look at this determinant right here. But you have to remember that it goes plus, then minus. So when I cross that out, the next determinant is 2 times 3, which is 6, minus 1 times 5, which is 5. See that? And then it goes plus C times, and then you cross then you get rid of this, you get rid of that, and you cross out C's row and C's column. And what's left over is this determinant right here, which is 2 times 2, which is 4, minus 3. Okay? So when you simplify that, you get 9 minus 10. Tell me if I make any mistakes. Negative 8, right? And then you get 6 minus 5, which is 1, but there's a negative inside in front of it, so it's minus b. And then you get 4 minus 3, which is, they won't always come out, plus c. Do you understand where I got that from?
Why is there the
No.
2 times 5 in the A?
Why is it minus b?
Wait, slow down, slow down, one question.
What the heck?
What's
I
the
don't
first question?
understand what one.
9 minus 10 is, this quantity is negative 1, right?
No, but why is there the negative 2 times 5 when there's no other, there's none of that in B and C?
What?
You just simplified it already.
Yeah, I just multiplied. So for B, it's 2 times 3, right? Which is 2 minus 1 times, what was this? 1 times 5, which is minus. I just, yeah, I did that.
You're at most the best way I can make it.
Okay, so that's how you figure out a determinant. So when you're doing a cross product, okay, when you're doing a cross product, you use a determinant to figure out what that cross product is. So, and what you're getting again is you are getting a vector that is perpendicular to both of those vectors, all right? So if you cross V cross W, what you do is you put your I, J, K up here. I, J, K instead of A, B, C. And then order is important. So if they want V cross W and W cross V, you're going to get 2 different things. They're opposites of each other, okay? So if I want to do V cross W, I'm going to put 2, 3, and 5 there. And then I'm going to do 1, 2, and 3. 1, 2, and 3 there. And that's my determinant, all right? So then I am going to cross out, go like that. And so, yes, sir.
What is going to?
What?
Oh, never mind.
That's W. This is the
This is for
the
B times
code.
B?
Yeah, V cross W.
It's
Okay?
3 minus 4.
And so I would get 3 times 3, 3 times 3, minus 1 times 5 in the I direction. Does everyone see where I got that from?
Yeah.
Okay, it's this determinant right here. Next step, it's always minus. So it goes plus, then it goes minus. And
2 times 5.
oh, 2 times 5, sorry.
Give me the same one as we just did.
Oh, it is going to be the same as the one I just did? Oh, it's exactly the same.
Yeah.
Sorry.
Oh, where?
And so this one is just going to come out to be negative I, okay? Sorry. Negative I, then what was it?
Minus j.
Minus J
Plus k.
plus K. So that would be V cross W. Now if I switch the order of these things, what's going to happen is this is going to flip signs. So it would be W cross V is going to go I plus J minus K. So in other words, say this is V over here and W over here. That one might return this vector, which is perpendicular to both of those. And the other one, W cross V, would return a vector going this way, okay? But in both cases, they're perpendicular to those 2 vectors. All right? V cross V, let's try that. So let's do V cross V. Let's get a fresh sheet of paper. I have infinite paper, don't I?
Yeah, but we don't.
You don't have infinite paper? Why not?
We're not treating
Is
it.
this the 90s?
Hey.
We're not- Oh, we're not in the 90s anymore. We're in the 2000s. 2010s.
A.
I never thought I'd even be alive this. Okay, so V cross W, V cross V. So what you're gonna do for that, let's try to do that. I, J, K, and you're gonna go 2, 3, 5, and 2, 3, 5 again. All right? So what that's gonna look like is the 3 times 5 minus 3 times 5, isn't it? In the I direction. Yes? Minus, hey, what do you think's gonna happen?
We're all gonna cancel
2 times 5 minus 2 times 5 minus 2 times 5 in the J direction, right? Plus 2 times 3 plus 2 times 3 minus 2 times 3, 6 minus 6 in the K direction. So what do you get out? 0 I minus 0 J minus 0 K, which kind of makes sense because if you have 2 vectors, right? Here's one vector and here's itself. There is no vector that is perpendicular to both those vectors, right? There's an infinite amount, well, it's the same vector, but there are an infinite amount of vectors that are perpendicular to that vector. That one would be perpendicular. This one coming out here would be perpendicular, right? This one going out here might be perpendicular. Basically, you'd get a whole plane or a whole circle worth of vectors that would be perpendicular.
So is that just like that solution?
Yeah, it's 0. It's 0 vector. Okay? Yeah, so going back, some properties of vectors, isn't that what's next? Ah, look! V cross V is equal to 0. V cross W is equal to the opposite of W cross V. This says you can take a cross product and multiply it by a scalar quantity, like a number, like 5 times V cross V is equal to 5 times V cross W, or V times 5 V cross 5 times W. Okay, so you can multiply a cross product by a scalar quantity. Also, the distributive property works for cross products. So U cross V plus W is equal to U cross V plus U cross W. Geometric properties of cross products. Right? The vector U cross V is orthogonal. We talked about that. That means at 90-degree angles. And U cross V, the magnitude of U cross V is equal to the magnitude of U times the magnitude of V times the sine of theta, where theta is the angle between them. Okay? And U cross V, the magnitude of U cross V is, it uses this property right here. The magnitude of U cross V is the area. I looked at the proof last night. And the magnitude of U cross V, that means if you take the square root of the coefficients and the square root of the coefficient squared, is the area of a parallelogram having U and V as adjacent sides. U cross V equals 0 if and only if U and V are parallel, or as we saw, if they're the same vector, right? Okay? So Reed is going to tell me how to do the next one. Go ahead. Do it, Reed.
So, what I think you do is first you do the 3, -2, and 1 for the IJK.
Okay.
And
You want? What do you want to find? Oh wait, find a vector orthogonal. And so, yeah, in this case, 3, -2, 1.
and then it'd be -1, 3, -1.
Ah, very good. Okay, and then what?
And then you would disregard I, and you multiply the diagonals for J and K, and you'd have 2 minus 6, 2 minus 3, I mean,
Uh-huh.
and you get -1.
Okay, but in the I direction.
Yeah.
Okay.
And then you do the same for J, and you would multiply.
What
by
goes here?
It would be a minus,
Yep.
and then it'd be 3 times -1 minus, or it'd be plus 1.
Yep.
And then you do the same for K, and it'd be minus, 3 times 3 plus 2.
Plus 2, because it's plus, it's minus this one.
Minus 2.
Minus 2. Indicate. So do you guys see what I did? Okay. This times this, minus this times this. Minus, don't forget this minus sign. People always get this wrong because they forget that the J is minus, okay? Minus this times this, minus this times this. That's why that's a plus. Plus this times this, minus this times this in the K. And then we simplify. That would be negative I. Negative 2 minus minus makes it plus 2J. And 7 plus 7K. So that would be a vector that is perpendicular to both of those vectors. Now also, I could have crossed them in either direction because another vector that would be perpendicular to that, right, would be positive I minus 2J minus 7K. It would just be going in the opposite direction. Yes, ma'am? 9 minus 2? 3, because negative 1 times negative 2 is positive 2, but it's always this minus, okay? So this is the one where I'm just going to tell you which sides they say are parallel. Because what happens, find the area of a parallelogram whose vertices are 0, 0, 3, negative 2. So in space, let's just kind of try to plot these points in 3D. So,
Use your 3D thing.
no, because in
Yeah, use it. Just
Use-
draw lines between them.
draw lines between them.
I'll make it easier for us to see it.
This is, it will?
Yeah, 'cause
Okay.
it's 3D graph.
Hold on. So, what's a wait, I have a question. What's the question? We're going to record this. So we're going to plot the point 0, 0, 0 in our 3D function grapher. So now I have to put a 0 in there. How do I do that?
We'll have to type it.
We'll have to type it in.
I can do it. Okay. 0. Is that a 0?
Yeah.
And then I have to go to here and put a 0. And then I have to go to here and hit a 0. And I hit a plot. Whoa, that's right there. That's pretty obvious, right? 3, 2, 1 is, so let's put that point. Negative 3?
Negative
Oh,
2. Negative
3,
2.
okay, just 2. 3, negative 2, negative 2, and 1.
I'm starting to get
And hit plot point. Whoa.
Whoa.
Is that cool? Okay. And then next point is negative 1, 3, negative 1. Negative
These are
1,
just like the dirtiest things that exist.
3, and negative 1. Negative 1. Plot point. Plot. And then, and then 2, 1, and 0. 2, 2, 1, and 0. And I hit plot points. Cool. Okay, so then what it says is that find the area of a parallelogram whose vertices are this. Okay? Now, part of the problem with that is that you don't know exactly where this parallelogram kind of is, because it might kind of be going this way, or it's kind of hard in 3D to tell.
Can you rotate it?
Where the-
Rotate it until we get like a better view.
Yeah.
Yeah, but let's,
Oh, dang it.
so maybe
That's kind of
This
Why
is
you
what
putting
my-
arrows on the vectors, or?
maybe that's what my parallelogram looks like. Why am I putting arrows? I don't know, because that's just what my tool did for it, okay? But what they tell me is, it says, what you have to do is multiply 2 of the adjacent sides and take the magnitude of it, okay? Now, one of these, to go from P1 to P2, so vector P1 to P2, okay? P1 to P2 is just going to be what? What's P1 to P2? by subtractive components.
I don't.
3 negative.
3i minus 2j plus k, right? And P1 to P3 are going to be negative 1i, right? Negative I plus 3j minus k. And P1 to P4 is going to be P1 to P4 is going to be
Why do we want to find P1 to P4?
2.
Wait, why are we using those indices?
Why are we trying? Why did we find P1 to P3?
No, I'm doing this problem down here.
Oh.
I just have space for it. Is 2 plus 2i plus j plus 0, right? And this,
How are you getting this one?
what?
How are you
I
getting-
just subtracted the endpoints from the start point,
Oh, okay.
right?
Yeah.
And you have to figure out which two vectors to cross, okay? Because if these two, see how these two don't add up to this one? See how P3 and P1 and 3 and P1 and 4 don't add up to this one, right? But if I add these two together, then I get this one. Do you see that? Okay? This gives you 2, this plus this gives you 2i. This plus this gives you j, and this plus this gives you 0, right? So what that must mean is that because there's more than one way when you're talking about 3D that this could be oriented in space, okay? And so, like, you don't know which sides are the adjacent sides and which sides are the diagonals, and to do that, so since this plus this, right, equals this, that must mean that which two sides are next to each other and which one is a diagonal.
The P1, P4 must be the diagonal.
Yes, since this one I get from adding this plus this, right? This plus this one adds up to this one, then these two must be adjacent sides. You see that? You follow what I did?
Yeah.
Okay? And so you kind of have to do a little test to see which ones you need to cross. So I'm going to cross this P1 to P2 with P1 to P3, and then I'm going to take the magnitude of it to find the area of this parallelogram in space. All right? So, and again, it doesn't matter which order you do this in, because why does it matter? It doesn't matter because you're taking the square root of the squares anyway at the end, right? And so I'm going to do -1, 3, -1, right? And, oops, I did it back. P1 to P2 is 3, -2, 1. And then I'm going to take the cross product of that, which in this case would be 3, right? 3, that's plus 2, so it's plus 2, but they're minus, so -2 in the I direction. Minus -1
Minus
plus 3, because it's minus, right? -1 plus 3 in the J direction, plus 2 minus 3, right? 2 minus 9. 2 minus 9 in the K direction. And then what I find when I simplify that is I get 1i. 2 minus makes minus 2j. 2 minus 9 is -7k, right? And then I want to take the magnitude of that, which is going to give me the area of this parallelogram. And that works out because of that formula, because the sine of, because that magnitude of this times the magnitude of that times the sine of theta in between them is going to be 0. Okay? So anyway, so when I do that, I get the magnitude of that is 1 squared plus negative 2 squared plus negative 7 squared. And when I do that, I get the square root of 1 plus 4 plus 49. Is that right? Did I do that right? I think so. Which is a square root of 54, which is whatever it is, okay? And that's the area of that parallelogram hanging out here in space. All right? And we're not quite done yet. The last thing, how do I get rid of this now? Shay,
Just
You
click the
click
big,
on it, press exit.
click the big, what?
just click the box.
Click this?
Not that one.
That's your recording.
That's where you click that. Oh, I have to get rid of this. I have to get rid of this. Click this. Click this. Make this big, right? There we go. Okay. So, so the volume of a parallel pipette, and what a parallel pipette is, it's, I don't even think I have a homework problem on this, but if you did have the volume of a parallel pipette, let me see if I can draw one. Parallel pipette is it's a three-dimensional parallelogram, right? So it'd have like side like this, side like this, side like this, and then it would have something kind of going up. Let's make some dotted lines here. It'd be kind of a I know it's not very parallel, but it'd be kind of a squished over parallelogram.
So it's kind of like a rectangular prism that, or like a stack of papers that someone kind of
Exactly.
moved over.
Yeah, it's kind of like a stack of papers that someone kind of moved over. Okay, so it'd be like this would be this. I'm so bad. I'm doing this all wrong. What the heck?
What?
This should have gone over to here. Okay.
No, you connected to you connected ones that are like non-adjacent. No, okay, not that one. That one.
Yeah, that one. Yeah. That's right. Okay. So, but it looks kind of like
What?
it.
No.
But a parallel pipette is a,
You're just confusing us.
I am, okay, so let's go to, I have a gallery of shapes. But anyway, a parallel pipette is a pushed over prism. Okay, so if you take a prism, you push it over to the side, and you take two of the sides, U cross V, and you multiply that by U cross W, and then you multiply that by the other side with the dot product, you would get the volume of that 3D shape. But so these sides have to all be parallel, and this has to make one of the bases have to be a parallelogram as well. All faces are parallel pipette, but I don't think I even have them. So that's the end.